Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
There we go. So Chris is going to be moving the slides on for me. So if you could just put it to the start, if you could, Chris, so I can see the agenda. So I can currently see slide 2. This is going to be fun, folks. If this is the start, that's all you have. Okay, no problem. So quick introduction then for me. My name is Catherine Julia Mort and I am the IB Knowledge Transfer Manager at KTN, and I am your chair and host for today's session on the green stage, where we'll be having some industrial presentations. In terms of the agenda, we will be hearing from 3 speakers. Next slide, please. First of all, I would just like to give you a bit of an introduction to the Innovate UK family, which KTN is a part of. I'm sure you've all heard of Innovate UK because they are the money providers, the funders, which we all love. So we're on the right-hand side, KTN, alongside the Catapult Centres. So we aim to connect and collaborate. Next slide, please. So KTN, we really exist to connect innovators with new partners and new opportunities beyond their existing thinking and really accelerating ambitious ideas into real world solutions, which you'll all be able to feel and see. So it's a pretty cool place to work. Next slide, please. So in terms of the net zero theme and this whole drive away from fossil fuels and petrochemicals, the KTN is focusing on, well, within the Chem and IP team, we're focusing on which feedstocks we'll be using in 2050, so quite a long way away, so we've got a bit of time to produce chemicals. So there's the scenario 1 is the traditional method to produce chemicals from oil and gas. Scenario 2 is from alternative feedstocks, CO2, plastics, waste and crops. So we're investigating scenario 2. Next slide, please. So really we're looking, the vision for the future, it really must embrace circular carbon feedstocks to be able to realise the potential of this chemical supply chain. Next slide, please. So this picture looks a bit busy. I love this picture though. It's an example of a future sustainable chemical supply chain, what it could look like. And the main message, I think, is that it really needs to involve thermal, carbon capture, biocatalysis and your traditional catalysis or catalytic technology to actually realise this. So I think we're all realising that it's not going to be one, it's going to be a combination of all in kind of a biorefinery type of scenario. Next slide, please. So we've already done some mapping work at KTN, or my colleagues have within the team, and we've mapped the UK innovation capability in alternative feedstocks to chemicals. So I've put the link there. I'm happy for my slides to be made available to whoever's online. So if you don't make a note of this now, then yeah, you'll be able to get these slides later on, but please do check it out. Next slide, please. So in terms of current activities, I am focusing on, it is around the net zero theme, and it's all around where IB and EB fits within this drive to net zero. Next slide, please. So at the moment, I am currently conducting a scoping exercise to understand these EB and IB opportunities. EB, for those who don't know, engineering biology, IB, industrial biotechnology. And I'm currently engaging with key stakeholders around our community via survey and follow-up interviews, really to understand the innovation landscape in more detail and identify any gaps in knowledge or capability. So I will be issuing a report in August, and hopefully we will then be issued further funding by Innovate UK so that we can carry out a follow-on project to deliver these recommendations. I'd love it if you guys are interested in being a part of this survey. It's very apt to the audience today. Please do get in contact with me. My email address is just shown on that slide. Next slide, please. So we are working as part of the BCB project, the Bioeconomy Cluster Builder project, which is ERDF funded in collaboration with iBioIC and Scottish Enterprise. Next slide, please. And in terms of alternative feedstocks, we're concentrating on 6, so it's all within this theme. So whiskey co-products, waste, MSG and food waste, agricultural, forestry, marine and carbon dioxide, so biomass and carbon dioxide capture and utilisation. So there's links there for previous webinars. Go back, there's so much good information there, and we're looking at project builder workshops in the future, so there's something for everyone. Next slide, please. In terms of the Bayes biomass strategy, I'm sure you were all aware of that. That was the call for evidence was due last week. So I did submit something on behalf of KTN as part of the information gathered from the BCB project. So please do look out for details on more engagement from Bayes around this, and do get involved. It's our chance to really say as a community how we want the biomass strategy shaped. Next slide, please. So this is just a slide with loads of information on, loads of links for you to follow to the map, to the manufacturing webinar series, and also to my lovely colleague Sheena Hindocha, who is working on circular carbon opportunities. So if you would like to learn more, please do email her, look us up online, and yeah, let's all work together. Next slide, please. Oh, I'm not sure whether you'll be able to see it. So we're going to move on without further ado to our industrial presentations. We don't have a Q&A session at the end of each presentation, so please do put your questions in the comments box and I will get to them later on. If we don't have time, then please let me know, contact me via email, and I will directly introduce you to the speakers and you can pick it up from there. So without further ado, it's over to Jim Woodger from Lanzatech, who's going to be talking us through sustainable aviation fuel. So over to you, Jim.
Thank you, Catherine. Let me just share my screen here. And hopefully we will be able to get up and running. Okay. Hopefully, A, you can hear me, and B, you can now see the slides. Thanks again, Catherine, for the introduction and the warm welcome. It's really great to be here as part of Wales Tech Week. Just again, by way of introduction to myself, I'm Jim Woodger, the Managing Director of Lanzatech UK. My background is as a chemical engineer with half my career with UOP Honeywell, licensing technology to the oil and gas industry and to renewables, and the second half in San Francisco with Solazyme, building businesses with products made from algae. I've recently joined the Lanzatech UK team to grow our group up bigger and to execute some of the exciting projects that we've got going on, particularly here in the UK. So I'll give you a bit of an introduction into Lanzatech as a company, highlight the gas fermentation and alcohol to jet technologies that we've commercialized, and in particular showcase for this audience the alcohol to jet project that is currently underway in South Wales. So hopefully we can now move forward. So firstly, a bit of context as why Lanzatech was born as a carbon recycling company. Well, in our mind, the key to climate change is that we have to rethink carbon. We have to believe that all carbon is precious and we should only use it when we really have to. So for example, we don't really need carbon for energy production. The levelized cost of renewable electricity is the same as the levelized cost of fossil-derived electricity. So we don't need carbon in our world for power production. But where we do need carbon is for chemicals and fuels, particularly as it's going to take a long time to displace fuels that are used, for example, in aviation and other heavy user industries. So in our mind, we need to reserve carbon for fuels and indeed for chemicals, since many of the things in our homes, from carpets to trainers, detergents to yoga pants, are derived from carbon. So our message is we need to think carefully about where our carbon comes from, to use it sparingly in the right applications, and to ensure that we recycle carbon as much as possible to keep it either in the ground, in use, and certainly not in the atmosphere. So it's hopefully a bit of context as to where we're coming from as Lanzatech. So here we are as a company. We've actually been in existence for over 15 years. Originally started in New Zealand, but now headquartered in Chicago in the US. We're a team of just over 200 people, having been through 5 equity rounds, raising almost $500 million in capital, both from venture capital, private equity, and also, as you see here, a number of strategic investors as well. And I'll share with you shortly the technology platforms that we've developed, which are backed up by a very strong IP portfolio. So looking at the platform technology that we've created, is based around fermentation. The same sort of fermentation that we all know today that takes sugars with yeast through to alcohol for our wine and beer, and to various other products as well. The difference being here that we use a bacteria, a biocatalyst, to produce ethanol from this fermentation process. Our feedstocks include industrial off-gases from steel mills and oil refineries, for example. We can use gases made from agricultural waste and municipal solid waste. And we can also use CO2 extracted from the atmosphere combined with green hydrogen. Basically anything with CO2, carbon monoxide and hydrogen we can use into our process to produce ethanol. That ethanol can be further used as road transportation fuel. It can be converted, as you'll see from another one of our technologies, the alcohol to jet technology, to fuels. And of course, it can be used for chemical applications as well, either directly into products or further converted from ethanol into things like polyethylene and so forth. Today, our platform is focused on that ethanol product, but in the future, we're also bringing out new types of biocatalyst that can directly go to other chemical building blocks, such as acetone, IPA, MEG, etc. The really clever part of this is the full recycling ability that we have. So when those consumer products have reached the end of their life, they can be gasified to create the gases that go back into the start of the process, completing that carbon cycle that I talked about at the start. Now, before we get ahead of ourselves, it sounds, of course, like science fiction, but in fact, it is science fact. Over the last 15 years, we've scaled up this process that I've just outlined from laboratory scale right the way through to now operating our first commercial gas fermentation plants. That first plant has been built in China and has been operating since 2018, and using steel mill off-gases has generated over 80,000 tons of ethanol so far and avoided the emission of 120,000 tons of CO2. Just this year, we started our second plant producing ethanol from ferroalloy off-gases in China. And as you can see, the first plant in Europe, in the Netherlands, is due to start up next year. From the map at the bottom of the chart, you can see that we've got a number of projects globally where we're going to be building out capacity. If we took all of the waste feedstocks that are available globally today, so the gases, the agricultural waste, the municipal solid waste, we could produce with our technology in excess of 500 billion gallons of ethanol. Of course, we're not going to do that completely, but it gives you an idea of the scale and the size of the opportunity that presents itself. So why ethanol, you might ask yourselves? Well, we see ethanol as the building block of the future. On the left-hand side of this chart, you can see that ethanol can be further converted to sustainable aviation fuel. More of that in just a moment. But on the right-hand side, you can also see that the ethanol can be used directly into consumer products, for example, for cleaning, or further derivatized into surfactants for laundry detergents, into PE and PET for packaging, and even into synthetic fibers for textiles. So we've worked with a number of partners you see here, Unilever, Total, Coty, L'Oreal, to demonstrate taking the gases, off-gases from steel mills to ethanol, and then further derivatizing into these various products. And we now have some consumer products on the shelves using these gas fermented products. So focusing in a little bit more then on the alcohol to jet technology. This technology has been scaled and can take any form of ethanol any source of ethanol available today or in the future. So it's feedstock agnostic. We can take first generation ethanol today, second generation ethanol from straw, for example, or indeed the ethanol produced by our own gas fermentation process. The products from this process are, you see here, the alcohol to jet synthetic paraffinic kerosene, A to J SPK, and also a byproduct of green diesel. The alcohol to jet SPK has been fully approved by ASTM for use in flight for commercial aviation in blends of up to 50% with fossil jet fuel. And you can see on the pictures there a couple of example demonstration flights that we performed, one in 2018 with Virgin Atlantic and one with ANA across the Pacific in 2019. So a fully proven process for taking the ethanol through to sustainable aviation fuel. So now we're in the process of scaling up that A to J platform, as well as you saw scaling up the gas fermentation platform. To do that, we've launched a spin-off company called Lanzatech, of which Lanzatech is a major investor, alongside Suncor, ANA, Mitsui, US DOE, British Airways and Shell. You may have seen some press releases on that. We've already had, since 2014, our own biorefinery demonstration scale facility operating in Georgia in the US. And next year, we expect to start up a 10 million gallon a year alcohol to jet facility at that same location. We're also doing a project under the Horizon 2020 program called Flight in the EU, which will be a 13 million gallon facility operational in 2024. And now we're looking at various other projects at even larger scale at various locations around the world. You know, key to see on the right hand of that slide is, of course, the UK being one of them. So very pleased to share with you some details of the Port Talbot alcohol to jet project that we're currently undertaking. And there are two elements to this project. Firstly, the inside battery limits there in the first box on the top, which is designing the actual plant itself, for which we will be starting the front-end engineering design in August, so very shortly. And then under the SWIC program, the South Wales Industrial Cluster, which has been funded under Innovate UK, we're working with Costain, Turley, Industry Wales and various other partners to do what we call the outside battery limits elements. So looking at selecting the final site, the OSPO engineering, and starting the permitting activities for this project. Ultimately, we believe that we should be able to start up in 2025, and this plant will produce over 100 million litres per year of alcohol to jet SPK. So when you blend that in with fossil jet fuel, you'll be producing between 200 million and 300 million litres a year of what's called sustainable aviation fuel. That's critical because it brings greater than 70% greenhouse gas savings compared to fossil fuel, provides significant investment in the South Wales region, and obviously the potential for a significant number of jobs as well. But also, we know at the start, this project will just take ethanol produced in the UK, second generation ethanol from the UK or indeed from Europe. But in the future, we can also envision where we will actually add our gas fermentation process upstream of that factory in order to take industrial off gases, for example, from the Tata Steelworks in Port Talbot, through gas fermentation to ethanol, and then through the alcohol to jet facility to make the green jet fuel. So a really exciting project that we're very pleased to be part of, and we believe that can be cost competitive with fossil jet fuel in the future. So in closing, just want to share with you a vision of the future as we see it, and take you on a journey to what we call a carbon smart world. So this is a world where we're making full use of industrial off gases, biomass and CO2 capture to generate either fuels or indeed carbon smart products that you can use in your homes and your lifestyle. So it's a world where you get to choose where your carbon comes from, the carbon in your products, the carbon in your transportation method, and the carbon in your personal belongings, and make sure that the carbon you select is one that can be recycled, reused and regenerated via the sort of technologies that I've outlined today. We believe we have those technologies ready to scale up that can be cost effective, and we have the partners and the consumer drive to be able to achieve it together. A good example of that is the Port Talbot project which we're working on, as I said, very actively. So I think ultimately from my side, just to say from our view is we don't want to leave any carbon behind, and we're very excited to be part of the programme that we've got outlined for you today. Thank you very much, and back to you, Catherine.
That was an amazing presentation. Very exciting that Port Talbot is a part of the future, up and coming, all this new innovation. Absolutely wonderful. Thank you very much. If anyone has a question for Jim, please could you put it in the comment section, and we'll make sure that we ask Jim at the end. Thank you very much. Now I would like to hand over to our next speaker, Paula Carey from Carbon8 Systems, who is talking around accelerated carbonation for CO2 capture. So Paula, over to you.
Thank you very much. I hope you can see the start of my presentation. Here we go. Yeah, so I'm Paula Carey. I'm one of the founding directors and currently the technical director of Carbon8 Systems, which is a classic spin-out from the University of Greenwich. I used to be an academic geologist, and about 20 years ago I started working on accelerated carbonation technology, and as a result we commercialized the technology in around 2006. And I jumped ship from the university in 2010 to take the company forward. So Carbon8 Systems has developed what's known as accelerated carbonation. This is a form of mineralization or permanent capture of CO2. So we've taken the technology from laboratory to full commercial scale. Currently we have 3 commercial plants operating in the UK under license, which are treating the waste from energy from waste, particularly what's known as air pollution control residues, where lime is injected into the flue gas and then collected to, well, the lime treats the emissions from the flue gas, and we then treat that lime using carbon dioxide. So the 3 sites in the UK are currently operating using CO2 that is captured from, for example, fertilizer factories. So it's purified and then tankered to the commercial site. In 2018, Carbon8 Systems developed a new system where we can capture the flue gas directly from a flue stack. So in the picture on the right-hand side here, you can see this is the flue stack from a cement works, and this is our plant. As it was just before we started to install it at VCAS in France, VCAS Cement Group. And you can just see here 2 stabbings in the flue stack, and the CO2 is taken directly from the flue stack, passes through our plant, and then any excess flue gas goes directly back into the stack. So the flue gas is, or the CO2 is extracted from the flue gas without any need for purification or other treatment. So this has made a great breakthrough for us in that we can develop this, we've developed this modular system where the containerized system can be installed very rapidly, and essentially it's a plug and play. So it's really applicable to hard to abate industries such as the cement industry, where they're producing a reactive residue that can be treated with the flue gas. So we can look at the cement industry. As I mentioned, we're already working in the energy from waste industry. We can look at biomass, particularly biomass CHP, where the biomass is being incinerated for power. The paper and pulp industry, again, where paper is made, the recycled, or the residues from paper recycling are burnt, producing a very reactive ash. And also the steel industry, where steel slags are also reactive to CO2. The reason why they're reactive to CO2 is that these types of industrial residues contain calcium and magnesium silicates, calcium oxide, calcium hydroxide. And if you get the conditions right, you can mix these materials with CO2 to form essentially carbonates. So in the middle there, you can see a very basic reaction, calcium oxide lime plus CO2 to give calcium carbonate. We've looked at over 120 different residue types in our laboratory and developed mixed designs for most of those. So it's a very widely applicable technology, not only to residues that contain those reactive materials, but to other difficult to handle hazardous wastes where you can actually add a reactive binder to the materials. Carbonation is a natural reaction. It will take place over years. There's an idea that, for example, you could crush up reactive rocks and spread them on land and allow them to react naturally with CO2 from the atmosphere in a process known as enhanced weathering. But that reaction takes years, and what we do is accelerate it so that in the reaction conditions we use, it takes a matter of minutes, 15 minutes instead of years. And in the process, you reduce the pH of these essentially alkaline residues. And by that method, you both stabilize and solidify the heavy metals and other contaminants within those residues. Because you're forming calcium carbonate, you're permanently capturing that CO2 in a very stable molecule. And unlike many other carbon dioxide utilization processes, the carbonation reaction is what's known as exothermic. It gives out energy rather than requiring a lot of energy to do the transformation of the carbon. So if you take carbon dioxide and you form calcium carbonate, it's a more stable form of the calcium, of the carbon dioxide, as opposed to when you're making chemicals or fuels or plastics. You have to raise the energy levels of the CO2, and it requires quite a lot of renewable energy to do that. When we engineer the system, we are currently engineering the system so that we can produce an end product which is, at the moment, a lightweight aggregate. So through the engineering of the mixture of the residue and the CO2, we produce an aggregate that can be used as a replacement, principally in concrete blocks. Also, we can use it in ready-mix concrete or potentially in green roofing. And for some of the residues, there's the potential to use the material as a fertilizer. So the benefits of the technology are really associated with the fact that we're dealing with problematic waste streams or residues from these industrial processes. And we're avoiding the cost of handling these residues, principally because they are destined for landfill. So we can save on the landfill tax, the landfill gate fees. Again, it's safe and permanent capture of the CO2, so we will be able to realize the value of that CO2 we've captured. It's quite important that within, for example, the discussions of the ETS and carbon taxes, that the permanent capture of CO2 is going to be the only part of the tax system that's going to justify payment or value for the CO2 captured. So along carbonation or mineralization alongside carbon capture and storage, which is considered to be the permanent capture. And then, of course, we can manufacture products that can then be sold as a replacement for natural aggregate, but we're also looking at the fact that we can actually manufacture some higher value products from that carbonation process. So just looking at the aggregates that are our stable product at the moment, importantly, the aggregate captures more CO2 in the process than is used in the process. So we can truly claim that the aggregates are carbon negative. The degree of carbon negativity depends very much on the residue that we're treating. All the different residues from these different processes or industrial processes that I talked about have different reactivity to the CO2. Where we're busy at the moment down at the VCAT cement works, the material is pretty reactive in that it can capture up to 300 kilograms per ton of residue. So that material there will be very carbon negative. The material is lightweight, so it's a replacement for other more energy intensive manufactured aggregates such as the expanded clay. It's similar to that expanded clay in that it has a high water absorbency, which gives it good insulating properties. And also some of our aggregates have what's known as hybrid properties. It can control the humidity in the atmosphere. So basically our aggregate is adaptable to a great many applications. So our participation in the South Wales Industrial Cluster is really important to us in that it's a good illustration of where utilisation is going to be much more important than the idea of carbon capture and storage. Because the cluster doesn't have a nearby area for storage, CCU has to have a much greater emphasis. The CO2 that is captured from the cluster is going to have to be shipped out if it's going to go to storage. So one of the things that Carbonate Systems is contributing to the cluster is looking at this potential for utilisation. If we talked about cement works, for example, commonly cement works are in locations that are away from the clusters. And again, once the CO2 is captured, it's going to be, utilisation is going to be really important. And because you can generate value from that utilisation, it's not reliant on government subsidies, which most of the carbon capture and storage projects are at the moment. So within the South Wales Industrial Cluster, there are several opportunities, not only for the current production of residues, but also there are areas where there are historic landfill residues that can act as a carbon sink. So I hope that's a good summary of where we are with Carbonate Systems, and I thank you very much for the invitation to present, and I look forward to receiving some questions. Thank you very much, Catherine.
Amazing. Thank you, Paula. Really interesting. Yeah, amazing to hear all the good stuff that's going on. So yeah, please do get the questions in the comments. And thank you for keeping to time, everyone. It's amazing. I wasn't expecting it. So we're going to go to our final speaker of the session from ERM, Molly. Now, Molly did tell me how to pronounce her last name. I'm going to say Iliffe. Go on, Molly. What is it?
Iliffe. It doesn't matter. No worries.
Iliffe. Okay, Molly Iliffe, and it is a beautiful name. And Molly is going to be talking around the Dolphyn project and green hydrogen at scale. So over to you, Molly.
Thanks, Catherine. Very much appreciated. Right. Okay. Can everyone see my screen? Can you let me know, Catherine, if that's on screen? I'll take that as a yes. Give me a yell if no one can see it. Okay. Hi everyone. Good afternoon. It's great to have the chance to chat to you about this really exciting project, which is the ERM Dolphyn project, which is an at-scale solution for generating green hydrogen from floating offshore wind. So my name is Molly. I am the Financial and Economics Manager for the ERM Dolphyn project, and I also lead ERM's capability around commercial and financial modelling of hydrogen and energy transition more generally. So I'm going to take you briefly through what the ERM Dolphyn concept is. We'll discuss the development timeline for the project. I'll also talk about the engagement that we're trying to do with the supply chain, and we're really keen to chat to any companies in the supply chain who are interested in chatting to us about how they can support the project. And I'll touch on some of the context and background to the project as well. On the right-hand side, you can see the whole of the team well, not the whole of the team, but the main people who are developing this project. So it's a very talented and hardworking team. So who is ERM, which is the company that I work for? So ERM is a leading global provider of environmental, health, safety, risk, social and sustainability related services. It operates across more than 40 countries and has more than 4,500 people. And in terms of our hydrogen capabilities, we've been involved in really every major project to do with hydrogen that's gone on in the UK, as well as working globally with clients across Asia and other areas of the world, looking at hydrogen opportunities. And our capabilities have recently been bolstered through the acquisition of E4 Tech, who's brought a lot more technical expertise on the hydrogen side. So what is the ERM Dolphyn concept that I'm speaking to you about today? So there's a couple of pictures of the concept on this slide, so you can see it from different angles. And basically it comprises a floating platform based on the Windfloat Atlantic design, on which there is an offshore wind turbine. So we're aiming for a 10 megawatt turbine initially, but moving quickly to 15 megawatts. And also on the platform, you have all of the equipment that you need in order to convert the electricity that's generated by the turbine into hydrogen. So you have electrolyzers, you also have desalination equipment, which can take seawater through a lift pump and pipework system, desalinate it, and then run it through the electrolyzer. You have backup power generation, because this is an off-grid solution. It's aimed to be built without any connection to the electricity grid. Then a flexible riser is used to export hydrogen from the platform to a trunk pipeline on the seabed. So because it's a floating concept, it can be deployed in very deep water, quite far from shore, which enables us to take advantage of good wind resource in these areas. In terms of some of the key design features that we've been pursuing in producing the concept, so we're pursuing a design which aims to be normally unmanned. So it runs autonomously. It can be operated from shore with a very detailed monitoring and control system. Also, we're aiming for very high reliability and availability, both to reduce unscheduled maintenance and also in terms of planning scheduled maintenance, because for offshore wind, the vessel costs associated with operation and maintenance can be a significant driver of the cost. At the moment, the design is based very much on a modular system, a sort of containerized solution with the major equipment items contained within their own buildings. But going forward, we're aiming to integrate the systems as far as possible, which then introduces cost savings associated with the platform. And we're also looking to ensure that as far as possible, we produce as much of the equipment in the UK with as low a carbon footprint as possible. So in a nutshell, that's the concept that is being developed. We've got quite a bit of funding from the UK government in order to develop the project, and we've been going through pre-feed activities for the 10 megawatt commercial demonstrator. And we're about to apply for our next phase of funding, which would then take us up to the final investment decision for the concept. How does this feed into the bigger picture? You know, it's all very well generating hydrogen, but what's the point really? So the 10 megawatt concept that we're looking to develop, we have a preferred site which is off the coast of Aberdeen, but we're also looking at other sites, including related to the South Wales industrial cluster and around other areas of the UK as well. Because hydrogen produced in bulk in this way can be key to decarbonising onshore transport and industry applications, as well as eventually, hopefully, we would see a repurposing of the whole UK natural gas network to hydrogen to enable the decarbonising of domestic applications as well, such as heating and catering appliances. So the Dolphyn project really feeds into onshore off-taker solutions, which can come from a wide range of different areas. And we're in touch with a lot of different types of off-takers who are interested in the hydrogen that we could produce. So on the transport side, for different transport applications, also for different industrial applications, some of which are also interested in the oxygen offtake that can be produced by the concept. And additionally, looking to blend into the gas network as well. So there's a lot of different solutions. And one of the important things for success of a project like this is to have your end-to-end strategy in mind. Otherwise, there's a little bit of a chicken and an egg situation in terms of your production and use of hydrogen need to align. This slide summarises the development plan for the concept. So we're progressing next year to undertake some small-scale trials to help us to de-risk some of the elements of the concept where we're taking, doing a bit of technological innovation. So we're looking to undertake those trials next year. Then we're moving to a commercial scale demonstrator project, which we're aiming to deploy in the summer of 2024, which would produce just under 900 tonnes of hydrogen per year. And then very quickly, we're also looking to engage with a number of different sites around the UK and globally to develop fields in the range of 100 to 300 megawatts. And moving to that kind of scale really helps to bring down the costs associated with the project, and also will help us to develop learnings which we can use at the next stage, which is the gigawatt scale projects from the early 2030s onwards, because it's from then that we really would expect to see a bulk hydrogen market developing, which will be looking for low-cost hydrogen supply at scale. ERM is not undertaking this project on our own. There are a number of other organisations which we're working in partnership with to help this project to happen. So we're working with Principal Power, who are designing the substructure based on the wind-float Atlantic design, which is already proven. We're also working with NEL, which is an established electrolyser manufacturer, and they're focusing on the electrolyser aspects of the concept. And we're also working in partnership with Doosan, which is focusing on the electrical engineering, particularly the integration of the electrolyser. Tractebel Engie is another important partner. They have a lot of relevant experience around subsea engineering, as do ODE. And Tractebel is focusing on the design of the substructure deck and the turbine interface, while ODE is focusing on the design of the top side, which includes a range of different equipment, including the desalination unit, hydrogen storage, and they're also looking at the export pipeline as well. And finally, we've engaged Lloyd's Register, which is undertaking independent third-party certification of the design. We're really keen to engage with the supply chain. We're running a range of supply chain events, and we have also developed a supply chain register for all of the key equipment items associated with the project. You can see on this slide there's a range of different elements that we'll be looking to procure for the project that we're hoping to be operational in 2024, and also for the larger scale projects. And we're really looking for partners who are keen to work in partnership with us, who see the wider opportunity. It's not just about putting a 10 megawatt project in the water. We're also looking at moving quickly to scale, optimizing the design, bringing down the costs, improving the performance, and ensuring that we can bring a reliable at-scale hydrogen production solution to market quickly. So we're really keen to engage with suppliers. And if you're interested in chatting around this, then you can reach out through the Dolphyn website or through the email address, which is at the end of these slides. So just a quick note around, this project doesn't exist in isolation. It exists within the wider sort of Scottish and also UK strategy around decarbonisation and the important role that hydrogen can play in that, particularly for some of the harder to decarbonise sectors where there may not be another technical solution to decarbonise other than hydrogen. So one of the reasons why we're looking at the northeast of Scotland as one of the sort of early sites associated with the concept is because of the Scottish industrial cluster and also the strong support in the area. But we're also in discussions with the South Wales industrial cluster. There's a lot of opportunities there and a recognition of the important role that hydrogen can play. And it isn't just an opportunity for the UK, there's a massive global opportunity here. There's an opportunity for the UK to generate hydrogen that can be used domestically or exported. There's also a global opportunity for us to develop this technology, use UK innovation, and then to sell that globally in areas which have deep water and strong domestic demand for hydrogen, but also, or that may be seeking to produce an at-scale export market once they've converted the hydrogen to ammonia or liquid organic hydrogen carriers or another export vector that makes sense. So there's the UK has a fantastic opportunity here to leverage its existing offshore wind resource and to produce a concept which can be deployed globally. So as I said, we're really keen to chat to anyone who's interested in the project and particularly around the supply chain. You can reach out through the ERM Dolphyn website, which is linked there, and you can also email directly if you wish. My email details are on this final slide. So thank you very much, and very keen to take questions if anyone has any questions.
Amazing. Thank you, Molly. Great presentation. Some good stuff going on in the UK at the moment in terms of innovation and sustainable future and green circular energy. Wonderful. I haven't, if I can invite all the speakers to turn on their cameras, please, and unmute yourselves. We're going to do a bit of a mini panel session. I can't see any questions that have come in on the comments box. So maybe people are feeling a little bit shy and would rather contact you directly, which is fine. So I have a couple of questions that I would like to ask you guys. And we've got about 10 minutes, so a couple of minutes each. So the first question I would like to ask you is, in terms of the innovation landscape in the UK, how has that helped you facilitate the commercialization of your technologies? What's been the best thing the UK has been able to offer you in terms of this innovation network or landscape that's really helped your business go forward? And I'm going to go with Jim first. So over to you, Jim.
Yeah, thanks, Catherine. Great question. I caveat my answer by saying that I've only recently moved back to the UK and I'm reaping the benefits of what colleagues have done in the past. But I think two things that have struck me. One is the level of engagement and conversation that's been going on between industry and between government departments, whether it's BIS, Innovate UK, entities like that, about what is it that the industry needs, what is it that governments and supporting bodies can actually offer, and try to find that middle ground of solutions and that package of solutions that can help. So I think if I cast back to sort of a decade ago when I was in the UK, that clearly has changed, which I think is fantastic. There's definitely a strong alignment on what the end goal is. It's now a question of how do we find our way of getting there. So that jumps out at me. And I think also as part of that, the willingness of government to support the feasibility studies, the basic engineering design, and the steps that are needed to get projects defined and towards a final investment decision, I think has been very good. With our Port Talbot project, it started in 2018 with a feasibility study funded by F4C. When you're doing first of a kind, new to the world technologies, putting money in with a guarantee of no return because it's early development work is difficult to convince investors, and having the UK government support those sort of things brings projects here and starts the process. So those are my initial thoughts.
That's brilliant, because that's my day job. So I'm really glad to hear that we're doing something right.
We didn't pre-agree with that, honestly.
We didn't, no. So yeah, if we can facilitate this de-risking process so that you ultimately get private investment to commercialize on a much bigger scale, then that's the ultimate aim, right? So it sounds like all the right people are talking to each other and conveying the information across the supply chain. So that's really good to hear. I know there's always room for improvement, but it's good at least that you were happy, Jim. So that's good. Molly, can I come to you next, please?
Yeah, no, I mean, I'd echo a lot of what Jim said. The funding which the UK government made available through the hydrogen supply competition was really critical in terms of undertaking pre-feed activities associated with the ERM Dolphyn project and some of the other funded projects that are available looking at hydrogen use. So, for example, around hydrogen for green distilleries, also hydrogen in the context of industrial clusters, will be really key to ensuring the success of a project like this. But the UK is in a fantastic position. There's so many transferable skills that it has from its legacy oil and gas sector, legacy engineering expertise, that I think the UK is in an excellent position. We just need the funding to be targeted correctly. So
yeah, I totally agree with you there. I've come from Wilton, CPI at Wilton, which used to be the ICI kind of hub or headquarters, and there's so many that area of the UK is just, it's a wealth of expertise, that people are transferring their skills into these new sectors. So yeah, we are in a privileged position for sure. And Paula, what about you and your technology journey?
Well, we also have to say thank you to Innovate UK and its predecessors, TSB, because that helped us on our way back in 2010, and then more recently in 2019, we've had 2 reasonable grants from Innovate UK, just assisting us with developing of our pilot plants and getting us going as a company. Also in the UK, we have a special, I think I'll say in the UK, the English Environment Agency, everybody loves to hate them, but actually the way we have clear waste management legislation, it does help in a technology such as ours where we're looking at repurposing and recycling waste. And I think it's a good example of the Environment Agency is actually fairly pragmatic about looking at these recycling opportunities and allowing them to go ahead. Where in Europe, the situation is a lot more confused, even though they're all supposed to be part of the same waste directive. Individual states have different regulations, and it's actually quite difficult to navigate through that system. Whereas in the UK, I think we have a good pragmatic regulation system, which is clear.
Yeah, brilliant. Well, we're doing lots of good things by the sound of it. So I have one question that's come in, and then I've got one final one for you guys. So this is for you. I think this is for you, Jim. Yes, it is. Question for Jim. This is from Brian Eddy. And he says, great to see the progress made with the steel mill off gases, but do you have plans to capture or utilise the green ethanol during the flight of aircraft?
Okay, thanks for the
That
question,
makes sense
Brian.
to you, Jim?
Yeah, I think so. So, yes, we've made good progress with capturing the steel mill off gases to produce ethanol. And if I understood correctly, the second part of our technology takes the ethanol and turns it into the green jet fuel that it can be used in aircraft. I'm not sure, Eddie, if that's what you were getting at. And that's the Port Talbot project is about taking ethanol to make the synthetic paraffinic kerosene to use in aircraft flight. It's fully approved for use. I'm not sure if you're referring to trying to capture gases on the outlets of engines during flight or anything like that, but by all means, get in touch with me and we can talk about it further. I'm not sure, Catherine, how you interpret the question in that regard.
Yeah, that's how I interpreted, and it sounds like you are already doing that, and it's a main focus of your business. Brian, if you would like to be introduced to Jim, just email me and I can do that, and you can have further discussions on that. And thank you for your question. So my final question is a bit of a big up to Wales, and I want to know, why should people come to Wales to commercialise technologies? What has Wales got to offer apart from Joe's ice cream parlour? If you haven't been, you need to go. Apart from that, what has Wales got to offer? Molly?
Yeah, so I think Wales, so it has anchor demand in terms of the South Wales Industrial Cluster, which is a significant benefit. It has, I'm speaking from the context of my concept here and other developers which are looking to routes to market for their hydrogen production options. It's got sort of excellent wind resource. It's got legacy industrial skills and infrastructure. It's got potential for storage as well. It has excellent transport routes, which can provide a market for hydrogen and also a route for transporting hydrogen to other users as well. So there's a range of different benefits in terms of Wales as a location from the perspective of this type of technology.
Sounds wonderful. What about you, Paula?
Apart from being a very nice place to be.
Yeah, it's wonderful. We need to move back home.
Yes, as a Swansea-born girl, yes. So it would be nice to go back home. I think from our point of view, the industries, particularly in the South Wales cluster, are just the appropriate ones for our business. And because there's the legacy of industrial sites, there's space and there's opportunities for us. But they're not restricted to South Wales. I mean, there are cement plants up in the north of Wales as well, and it's a convenient place to do some exciting things.
Sounds great.
Lots of CO2 to capture.
Yes, I would ask you, Jim, but I think we are out of time. But I'm sure everyone will echo how wonderful Wales is, and we invite everyone to bring their new technologies because it's all got it all going on, infrastructure and everything. So thank you once again from me. Wonderful session, great presentations, very interesting, and thank you for all those that are listening in.
Thank you very much, Catherine. Thank you very much.
Thanks, everyone.
Brilliant.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.